Okay, I'm going to be working on number 5 from the assignment. Before we get really heavily into the content of 5, I want to remind everyone of these 5 statements that are all equivalent. So that means if one of them is true, they're all true, okay? Because we're going to be able to relate some of these in this problem, but in another problem you might need to call on a different one. So if you're watching the video, good time just to be reminded that these are all saying the same thing. If one is true, they're all true. So f has a 0 at x equals c. Then we also know that the graph of f has an x-intercept at c. And we also know that x minus c will be a factor of f. And if we're a factor, we know that we have a 0 remainder if we divide f by x minus c. And then this is really the definition of being a 0. So make sure you understand that number 1 and number 5 are always equivalent because they're the definition. What does it mean to be a 0? It means you can plug that value into the function and the output is 0. That's the one we're going to be using today, and we'll connect it to number 3 as well. So for number 5, I have a table, and I need to build a function from this table. Okay, so it gives me a whole bunch of values, and if I start looking at some of these values, I have the values of 0, 0, 7, 0, 12, 10. Notice that one's different. It's not a 0. When you plug in 12, you get out 10. Plug in 12, you get out 10. It's not a 0. That's going to be important. Also 18, 0, and 24, 0. Okay, and the top row is representing the time in hours. The bottom row is representing the temperature in degrees Celsius. Okay, so I have a little t and a big T. Sometimes that's kind of annoying that I have 2 t's in the problem, but I really just have to respect these directions. If I start changing this to x's, that's fine, but realize WebAssign is requesting t's, so if I want full credit, I'm going to have to use t's. Okay, so this is my entire information. I need to build a 4th degree polynomial from this. Okay, so it's giving me the form f of little t, not f of x. Little t is my input, my time is my input, my temperature is my output, my function's name is f. So I'm looking at those that are actually zeros. I'm going to put a star underneath them. They're the values that when you plug the input into the function, the output is 0. So it's not that one. It is that one. So notice I have 4 of those values, and it is searching for a 4th degree polynomial. Okay, so each of these values is going to correspond to a factor. Okay, so notice 0 is a 0, looking at the top row here, because when I plug it in, I get out 0. So that means x minus 0 is a factor. Again, I'm not going to write x, I'm going to write our input value, t. And for this, if you just want to write t instead of t minus 0, that is acceptable. The next 0 is 7. Plug it into the function, the output is 0. So that means t minus 7 is also a factor. Not a 0, not going to become a factor. Is a 0. T minus 18 will become a factor. Similarly, t minus 24 is a factor. Okay, so I have this nice factored version. It is 4th degree because if I multiply all these factors out, I would have t to the 4th. The issue is I have not used this piece of information. Well, they gave it to me for a reason. It's going to be useful, and you've used this type of information before. This is an additional point. This is like saying when the input is 12, the output is 10. So think about what you might have done on a previous assignment when you were given this additional point. Okay, that additional point tells me that I probably have not an extra factor, but a coefficient out front. So I'm plugging in a little c for coefficient. I think the textbook uses a. Just use whatever makes sense to you. But I have an unknown number out front that I need to solve for with this additional piece of information. Input 12, output 10. So all the little t's are becoming 12. I'm going to do this arithmetic here. 12 minus 7. 12 minus 18. 12 minus 24. And setting it all equal to 10, solving for c. Okay, so I am going to employ the use of the calculator here. I know 12 times 5 is 60. 6 times 12 is 72. So I have a 60 times a 72. And I get 4,320. Divide by that number to solve for c, and I'll have 10 divided by 4,320. I can cancel a 0. They, like a factor of 10 goes into both. So I'll have 1 over 432 is my coefficient. So I need to piece all this together. Oh, wait, I'm on a whiteboard. Let me think about how I can make this easier. I now know my C value. I'm going to plug it in right here. 1 over 432. And this is the answer for the function that satisfies that table given. Okay, so realize I used these two quite heavily, but for the graphing questions, you might use 2 and 3 quite heavily. But don't neglect the fact that you may also be given an extra point that will contribute to a coefficient. So there's just some hints for the graphing problems as well. All right, good luck.